Hello all. So we're moving on to chapter 21 and we're going to discuss the respiratory system. And the respiratory system has one main function, and that is to allow exchange of gases between the blood and the environment. And to do that, you have to have an organ that has a lot of surface area for exchange between, again, the air and the blood. And also you need to be able to breathe, which means pulmonary ventilation. You need to be able to bring air into that organ and push air out. And so we're going to talk about how we do that. And that passageway through which we move air is called your respiratory tract, and it has two main portions functionally. One is the conducting portion, and that just moves air, right? You're not doing any sort of gas exchange at that point. And the second is the respiratory portion. And the respiratory portion is the part of your respiratory tract where you actually have diffusion of oxygen from your lungs into your blood and CO2 from your blood back into your lungs. This is where we have structures called alveoli, which are made of simple squamous epithelium, which allows you, again, to have some exchange of gases. So if functionally we divide the respiratory tract into the conducting portion and the respiratory portion, anatomically or structurally, we divide it into the upper respiratory tract and the lower respiratory tract. The upper respiratory tract is what brings the air in, filters it, and warms it, in your nasal cavity, humidifies that dry incoming air, and it protects your lower respiratory tract by doing that. And when I talk about the upper respiratory tract, I'm talking about your nose, nasal cavity, pharynx, all those places where if you got some irritant in there, like pepper or dust, you would sneeze rather than cough. So again, here we're talking about everything up here, your nose, your nasal cavity, and your pharynx, leading all the way down to the larynx, and the larynx is going to be the beginning of the lower respiratory tract. Now the lower respiratory tract is a little bit more sensitive. It's your pharynx and trachea on down into your bronchi and into the lungs, your alveoli. And this is where you actually have exchange of gases at the end. So the entire respiratory portion of your respiratory tract is in the lower respiratory system. And this is where if you got an irritant in there, you would cough to get rid of it instead of sneezing. So this includes your larynx, which is your voice box, your trachea or your windpipe, and then your primary, secondary, and tertiary bronchi, which then branch into smaller and smaller bronchioles, and then eventually you get to your alveoli, and these are the thin pieces of tissue that are covered with capillaries where you actually exchange gases. And the primary function of all these structures is to allow for gas exchange, to bring oxygen in to get rid of CO2. But along the way, we also do some protection of those tissues, right? So we have mucous membranes that trap dirt and bacteria, etc., on the way in. We also have an olfactory epithelium that detects certain chemicals, so that we can, sniff the milk to see if it's still good. We can walk into a room, smell baking bread, and it can lead us to something delicious and nutritious. And we also use our respiratory system for communication, right? For talking and singing, as I'm doing right now. Well, talking right now. I'll spare you the singing. And a big part of the way that you defend yourself in your respiratory system is your mucous membrane and mucus escalator. So whenever you have places that are open to the outside world in your body, they're going to be in danger of infection and invasion. And, you're literally breathing the outside world into your body. So this is a vulnerable spot. And so you have mucous membranes all the way down through your respiratory tract. And you have these goblet mucus cells that produce the mucus, and they trap that dirt, that bacteria, viruses, whatever, and prevent it from going down. You also have some macrophages that will eat some of that stuff up, but essentially you end up getting this dirty mucus inside, and you don't just want dirty mucus inside your respiratory tract, so you have cilia along much of your respiratory tract to push that dirty mucus up. And then eventually you can, or however you get rid of your mucus. Probably better to blow the nose during COVID times. So much of the respiratory tract is lined with that respiratory mucosa, and that is made of pseudostratified ciliated columnar epithelium, which I know was your favorite type of tissue in Bio 151. Pseudostratified ciliated columnar epithelium. Again, it has those cilia and those mucus cells, so they trap the dust and push it back up. So, starting around your nasal cavity on down, much of it is layered with respiratory mucosa. But that's not all. In some places, like in the, let's say your mouth and your oropharynx and laryngopharynx, the parts of your respiratory tract that also have food moving down them, because for some dumb reason we put food and air down the same pathway for at least a while. I don't know about you, but when I eat, it's a little bit nuts. I have friends that won't eat wings with me. I'm ravenous. And so I am going to lose cells, right? I'm going to scrape off cells as I'm eating. And so I have to have multiple layers of cells. And so stratified squamous epithelium is what you find in your mouth, and then portions of the pharynx where food is going to be. This means that if you scrape off some cells, it's not a big deal. You have more cells beneath. And it also means they're squamous, so they're small, cheap cells. Not a big deal if you lose a few. So any place that you have friction or food, you're going to have stratified squamous epithelium. And then we also have simple squamous epithelium, where we have gas exchange in the respiratory surfaces. So simple squamous epithelium is the thinnest possible epithelial layer that we can have, and that means it's easier for diffusion of gases to occur. And so on the respiratory portion of your respiratory tract, where we're actually having gas exchange, where there are alveoli, it's simple squamous epithelium. So nasal cavity, and then skip part of your throat, but then begin again in the pharynx and all the way down here. Most of this is pseudostratified ciliated columnar epithelium, or respiratory mucosa. The actual alveoli are simple squamous epithelium. We have a couple places with cuboidal epithelium that we'll talk about so that they can secrete things within your lungs. These simple squamous epithelial cells don't secrete anything because they're too small to make stuff. And then you have stratified squamous epithelium in your throat, where you have food, and also in the pickable part of your nose, right? In the little vestibule there, you need to have some stratified squamous epithelium. Let's take a look at the upper respiratory tract. So it starts with your nose, and the nose holes that you have are called your external nares, your nostrils, or your external nares. And then the structure of your nose is made up of your nasal bones up here, and then nasal cartilages up here, and then they form a septum in the middle, so that really you're dividing your nose into two halves, left and right. You may remember from Bio 51 that around your nose you have the paranasal sinuses, and these are named after the bones that they're inside: maxillary, frontal, ethmoid, and sphenoid, and these are really just open spaces in these bones that are lined with mucous membrane, and they produce mucuses that drain into the nasal cavity, and they keep it moist and keep it clean. They also give you some resonance for your voice, so they may be important in terms of vocalizing as well. And then we breathe air in through those nostrils, and it comes into our nasal cavity. And your nasal cavity is full of mucus, and that allows you to trap some junk, but it also allows you to humidify a lot of that air. It warms up the air. Cold, dry air is much, much harder to allow diffusion to occur with in your lungs, because ultimately you have to diffuse into fluid because your blood is fluid, and so you want moist air coming in. This is why it's harder to breathe on like a cold winter day when you go for a run. So we have to warm up and moisten that air before it gets into the lungs, and then on the way out we reabsorb some of that heat and water so that we don't lose a ton of fluid and heat to the environment. And here, this is obviously a cross-section of a face. You can see the nasal septum in between the two sides, and that is made of your vomer at the bottom, and then of the perpendicular plate of your ethmoid up top. And you can see these three things here are conchae, right? Nasoconchae, and they cause some swirling of the air on the way in. They cause turbulence, just like we talked about with blood flow. And that turbulence allows every bit of air as it swirls around, instead of just going straight down into your lungs, it forces it to touch the side of your nasal cavity where there's mucus, and if it has any junk in it, it gets trapped, and it also warms and moistens that air. Also allows you to smell anything that's in the air, because more of that air is going to swirl and contact your olfactory epithelium. And then that air continues to move back through your nasal cavity into your throat. And the scientific word for throat is pharynx. Not pharynx, pharynx. And you have three main regions of your pharynx. The first is the nasopharynx. And as you might expect, the nasopharynx is directly behind your nasal cavity. It's the top part of your throat. This is where you have a meatus that opens up to the auditory tube in your middle ear. So this is why you have ear, nose, and throat doctors. It's all connected. Then we move down into our oropharynx, which is the throat behind your mouth, right, behind your oral cavity. And then down a little further into your laryngopharynx, which is the throat right by your larynx, hence laryngopharynx. And so here we can see behind the nasal cavity is the nasopharynx, then the oropharynx behind the oral cavity, and the laryngopharynx down here by the larynx. And, along this way, we've had food and air taking the same path. Now is where we split. Food continues to go down the esophagus. Air comes over here to the larynx. And you have a whole structure called a glottis with an epiglottis on top that's at the top of the larynx, at the top of the voice box, and it's there to prevent food from accidentally going down your trachea, down your windpipe. So here's a back view of this epiglottis. Here's a side view. It will fold down here to cover up the trachea. This is a front view. It folds down when we swallow, making sure that food doesn't go down the trachea. Now, sometimes if you happen to laugh while you're swallowing, it opens up to let the air out, and then food can drop in. And that's why sometimes you laugh while you're eating or drinking, and you can end up coughing a lot. In the front of this, we have thyroid cartilage, which is this big set of cartilage that helps protect the front of your larynx. You may notice a big bump here that's called your laryngeal prominence. We will sometimes call that the Adam's apple. Women have it too, but it's more prominent in men because testosterone tends to make it bigger. Below the thyroid cartilage, you have the cricoid cartilage, which is down under, just like Australia is. And cricoid sounds like crikey to me. And then if you go around the back, you can see this is the back of the cricoid cartilage, and then you have these talons that shoot up called arytenoid cartilages here. And then now in the trachea, you have cartilage rings keeping that trachea from collapsing. Below your glottis is your epiglottis, and this, again, originally probably evolved to prevent food from dropping down into your trachea, but now, in addition to vestibular folds on the outside, on the inside you have your vocal folds, or your vocal cords, and these are what vibrate to make sound when you breathe out. So vestibular fold, vocal fold, and we stretch them. And if you stretch them, it increases the frequency and makes a higher noise. And as you loosen them, it makes a lower frequency for a lower noise. And that's how you dictate pitch. You dictate loudness by the amplitude rather than the frequency, and that has to do with how much air you're blowing across. But all your larynx can do is phonation, so making a sound like right? We have to have teeth and lips and a tongue to articulate, to mold that sound into something resembling speech. And now, we have very complicated speech. That's one of the things that sets us aside from other animals, is the depth of our communication. And we have a lot to thank to our larynx as well as our lips, teeth, and tongue for that talent.